All right, let's try our next binary tree question. Populating next right pointers in each node. Okay, you are given a perfect binary tree where all leaves are on the same level and every parent has two childs. Okay, so I'm guessing perfect means it's this like super dense, well, completely dense. The binary tree has the following definition. Okay, so this is our, yeah. So there's a value, a left, right, and the next. What is next? Populate each pointer to point to its next right node. Hmm, I see. I see. So we know for a fact that our first case, the node, it is a node, right? Yeah. So we do know that the first node will always point to next. So we can write that first. This is always true. The first node will always point to none. Now what we can do is we can have two pointers because, oh yeah, so this is like recursion as well. But once we go into the child, we'll have two pointers. So let's say, so we're in the very top and then we go down one layer, we go down a layer. Then we'll have a pointer to our left one and our right one. But then how do we know if the right should point to null? We can actually compile. So let's not even think about this grandchild level right now. Let's just think about this middle child. So we've done it. So I think, oops. So we do need some. Well, it's not DFS, I'd say. It's more like a uh, call it recursion. I'm guessing we're gonna pass down the node, something like this, right? So the left is gonna be, and the right is gonna be node dot right. Strictly just looking at it, so strictly just looking at it from this level, we can see that the left node will point towards the right node. Yeah, I mean, that's right. But then how do we know? And then the right node is going to be none, right? But then now the problem is if we call recursion, the left, so we'll go down, this will point towards the right, this will point towards none, and this will point. But then we need to figure out this 5 and 6 part there. Like each subtree, but then how does the right know? So it must happen in the parents. Wait. So that's the problem. How do we ensure? So we have a global pointer. So this points to none. That's the base case. But okay, so the left one will always have a right pointer, but the right one will always be none. If and only if it's the very right node. So if it's the very right node, it will point towards none. So if it's the very right node for its given level, it'll point towards none. Hmm. I might try to do something freaky. We don't know the length of it all. No, we don't. Damn, I was gonna do like if it's 8, you can square root it by 2 and 3, right? So that means there's 3 levels. And then for each level, I could simply link the nodes together, and then the very end of the level would point towards right. But that doesn't work. I'm gonna add it to a queue. Should we add it to a queue? Maybe we can. Maybe a tuple. Do we need to put in tuple? So if it's not like that, I think I need a pointer approach because if I pop, if I pop left, right, and then that's gonna point towards. How do I know what to point it towards? I need to point it towards the next node, which is in the queue. Yeah, should I try that? But does that work? This is that full screen. 6 out of... It's the same thing. 2. It's gonna have 2 and then 3, right? For range 2, so all in 1. It's not. Right, all 1 if it's 1. Wait, this is true, yeah. I do want it to break. Two needs to point to 3. But 2 ends up pointing to null. Okay, well that was useless. Okay, let's go through our first case then. Maybe that may be easier to see where the problem actually happens. So we append our first node. It's going to be 1 and d, so range, so 0. So it does it 1, appends this node for a range length of level, so 1. So it's the exact same thing. 1 if 0 equals 1, 0, and the next is none, break. Okay, cool. Oh, but we can't break here. Sure, I'm just gonna add these first. None. Just keep returning the left ones. Okay. So left and right. So I put in 1. So I penned 2 and then 3. Next. Okay, so runs first time. Good. So it pins 2 and then 3. So we go to 2. We do it. So we add these 2. And for 2, we add in 4 and 5. No way! I did it! Yeah! Wait, I did it. Damn. Okay.